Systems are not a thing on their own. They're a way of analysing or understanding something else. Systems are made up of three parts: the input, the process, and the output. The input is something which is done to the system to make it work. This is usually a switch or button, or perhaps a sensor which triggers the system. The process is the thinking or responding part of the system. This reacts to the input and triggers the output. The output is what the system does when it senses an input. This is the result. We use this systems approach to think about products in a new way. One of the best ways to explain this is to use some examples. It is sometimes easiest to think about the input or output first, then work out what the process part of the system is doing afterwards. Here's an example, number one, a torch. The input. Well, ask yourself the question, what must I do to make the torch work? And the answer is, I have to press a button or move a switch. That's the input. The output. Ask yourself, what happens when you push the button or move the switch? The answer is, the light comes on. This is the output. Now the process is more complicated, but we need to do our best to work out what's happening between the input and the output, between the button being pressed and the light going on. This is the complex part and needs some careful thought. In a simple system like a torch, the battery provides power, but the electrical power can't get to the bulb until the switch is closed by pressing the button or moving the switch. Doing this closes the circuit and allows electricity to flow to the bulb. That's the process. This system is an electrical system. Here's another example, a door latch. We ask ourselves the same questions. Input, what do I have to do to make the door latch operate so I can open the door? Answer, I turn the doorknob or turn the door handle. Output, ask yourself what happens when I turn the doorknob or door handle. Answer, the latch moves back into the door. Look at the bottom right image. Process, what's happening between the door handle and the door latch moving back into the door? Well, the answer is there's a mechanism which turns the motion of the door handle into motion of the door latch. Have a look at the central picture to see what's going on inside your door. This system is a mechanical system. We've just looked at two different types of systems, electrical and mechanical. It can be helpful to think about the different types of systems because this gives us clues when we're trying to work out inputs, processes, and outputs. Some example of different types of systems are electrical, things like the lights in your house or a torch; mechanical, a door latch or bicycle brakes; electronic, things like a radio or an alarm clock; or software systems like those on your computer or your mobile phone. Now there are some misconceptions we need to talk about, things that people get wrong when using this approach to analyze a product. First of all, the input is not the same as the fuel or power source. The input to a lawnmower is not petrol. It's whatever you do to make the lawnmower work, such as turning a key or pulling a starter cord. In the same way, the input to a torch is not the electricity in the battery, because even if the battery is there, the torch won't light up until the input, that's the switch, is pressed. We need to think carefully about outputs in the same way. Be careful to identify the output the system is producing, not the results of the output. For example, the lawnmower is a system where the output is the spinning blades or the mower moving forward. Whether the lawnmower cuts grass depends on where you are operating the lawnmower. If you push it across the carpet at home, it won't be cutting grass, it'll be cutting carpet. Don't try this at home. Also, it's important to realize that not all outputs are useful. Lots of systems create outputs which are not helpful or useful. Noise, exhaust, pollution, these are all outputs from an engine. But the output we want to use is the movement created by the engine. That's the useful output. If you've understood everything about systems so far, have a think about this. The systems we've looked at so far have all been something called open loop systems. This means that the input activates the process, which then produces an output. The drawback to this is the system has no way of checking whether the output is still necessary. A more useful type of system is called a closed loop system. This type of system has feedback, perhaps using a sensor to see whether the output is still needed. This acts on the input to change the process and switch off the output. For example, a central heating system might be triggered by the room thermostat, that's the input, but we don't want it to stay running all the time. So the same thermostat has a feedback function which turns the heating off when the room is warm enough. Another simpler example might be a security light outside your house. Just like a torch, this switches on when there's an input, such as sensing the movement of someone outside your house. The feedback part of the system might be a timer, which waits 1 minute, then checks again for movement. If there's no movement after that time, the light switches off.